In this lecture, we take the example of DUIS. Now, the question is evaluate integration of log 1 plus ax square upon x square under the limit 0 to infinity with respect to x. Let I of a is equal to integration of log 1 plus ax square upon x square under the limit 0 to infinity with respect to x. Now we use DUIS rule number 1. So according to that, we have to differentiate left hand side with respect to a, so it will become dIdA, and in right hand side we use the differentiation under integral sign, so we have to just differentiate inside this value. So integration under the limit 0 to infinity and partial derivative of log 1 plus ax square upon x square with respect to a and whole dx. Now if you want to differentiate this log 1 plus ax square upon x square with respect to a, so x square is constant, so we can take outside, so which is given by integration of 1 upon x square, derivative or partial derivative of log 1 plus ax square with respect to a under the limit 0 to infinity and whole with respect to x. Now we know that what is the integration of log of a? It is nothing but 1 upon a, so which gives us 0 to integration under the limit 0 to infinity 1 upon x square. Derivative of log 1 plus ax square is 1 upon 1 plus ax square, and again derivative of 1 plus ax square with respect to a. The first one is 0 and the second one is x square. So we have 0 plus x square, which is given by x square with respect to x. Now this x square and this x square will cancel, so we have integration of 1 upon 1 plus ax square with respect to x under the limit 0 to infinity. Now if we take a outside from the given expression, so this we can take a outside, so 1 upon 1 divided by a times of 1 upon a plus ax square. So we have taken a, which was over there, we have taken outside. Or we can write down 1 upon a, this 1 upon a we have taken outside. Uh, Integration of 1 upon 1 plus 1 upon a can be written as 1 upon root a whole square plus x square under the limit 0 to infinity. Now we know that what is the integration of tan inverse of 1 upon, what is the integration of 1 upon x square plus a square with respect to x, it is nothing but 1 upon a tan inverse of x by a. So here in place of a it is 1 upon root a, and in place of x is x. So what is the integration? It is 1 upon a. 1 upon a means this 1 upon a, we have to first write this one, then we have to integrate this internal part. So 1 upon 1 root a, this is a, 1 upon root a is the a, tan inverse of x upon a, in place of a it is 1 upon root a under the limit 0 to infinity. So I think this is clear. Let me again explain it. We want to find out the integration of 1 upon 1 plus root a whole square plus x square. So it can be written as this 1 upon a, we have already written 1 upon a into 1 upon a, 1 upon a. So in place of a we can write down 1 upon root a into tan inverse, and what is the numerator? It is x, and denominator 1 upon root a under the limit 0 to infinity. Now it is this root a goes to numerator, and this e can be written as root a into root a, then tan inverse of x upon x, and this root a goes to numerator. It will multiply with x into root a under the limit 0 to infinity. Now if you put the upper limit and lower limit both, so this root a will cancel. We have 1 upon root a and tan inverse of infinity minus tan inverse of 0. But we know that what is tan inverse of infinity? It is pi by 2 minus tan inverse of 0 is 0. So we have dIdA, which is equal to pi upon 2 root a. Pi upon 2 root a. This is variable separable differential equation. So we can separate the variables and integrate it. So separating variables and integrating, we get integration of di is equal to pi by 2 integration of dA upon root a plus c. And now if we integrate it, so what is this root a goes to numerator and it can be written as a to the power minus half. A to the power minus half. And what is the derivative of a to the power minus half? It is this pi by 2. We are writing same thing. We are multiplying. We are 8. What is the integration of a to the power minus 1 by 2? It is a to the power minus 1 by 2 plus 1 whole divided by minus 1 by 2 plus 1 plus c, because it is not the definite integral. Now if we simplify it, it is minus 1 by 2 plus 1. 1 is 1 by 2 and it is root a, because a to the power half, a to the power half is nothing but root a. So which is equal to this 1 by 2 and this will cancel, pi root a plus c. This is the value of integration of I di r, which can be written as I. So therefore where c is integrating constant, which implies I alpha equal to pi root a plus c. Let us give it example number, equation number 2. Now we have to calculate the value of c from equations 1 and 2. Putting a equal to 0 in equation number 2 and also in equation number 1, we have from 1, what is equation number 1? I of alpha, I of 0 is equal to integration under the limit 0 to infinity log of 1 plus 0 upon x square dx. So log of 1 is again 0. This will become log of 1 is 0 upon x square is 1 upon log of 1 upon x square under the limit 0 to infinity with respect to x. But log of 1 is what? It is nothing but 0. So integration of 0 with respect to x is 0. From 2, we have I of a, I of 0, which is equal to pi root over 0 means 0 plus c, which gives us c is equal to I of 0. And so if you put the value of c in the equation number 2, and what is the value of I of 0? I of 0 is nothing but 0. So we can write down, hence 2 becomes I of alpha, which is equal to pi root a. So this is the desired value of the given integral, hence proved. Thank you.